In today's video, we're going to talk about the law of sines. We're going to find the area of oblique triangles, and we're going to use the law of sines to solve oblique triangles in the two situations if we're given information in the form of angle, angle, side, or angle, side, angle. And in the next video, we're going to look at the law of sines for solving oblique triangles if we're given side, side, angle. So what is an oblique triangle? A triangle that is not a right triangle is called an oblique triangle. First, let's talk about how to find the area of oblique triangles. So let's say we're given a triangle that's not a right triangle. And I'm going to label the angles with uppercase letters A, B, and C. Now in the past, how we found the area of a triangle is it's going to be equal to 1/2 base times height. Well, the height of the triangle is going to be this distance here, which I'll label H. And our side opposite angle A is little a, side opposite angle B is little b, side opposite angle C is little c. In this case, and in this example, our base of our triangle would be side C. Now we know the formula for area of a triangle is 1/2 base times height. So in this example here, that would be 1/2, and our base would be C, and our height, well, we don't know height, but we can use our right triangle trig because notice I've formed a right triangle with this dashed line. And if I look at angle A here, the sine of angle A is equal to H over B because, again, sine is equal to opposite over hypotenuse. Solving this equation for H, we get H is equal to B sine of A. So we have a new formula. Solving for oblique triangles, you can find the area of an oblique triangle as equal to 1/2 side BC times sine of A. So 1/2 the product of the lengths of two sides times the sine of their included angle. So notice the key with this is my two sides I have to use, this side C and this side side B here, form the angle that I'm using, that I'm finding the sine of. So sine of angle A. They form the legs of that angle we look at. It has to be in this form in order to use this formula for finding area of an oblique triangle. So it doesn't matter which angle you use. Let's say I wanted to figure out the area and I have information about angle B. So area would be equal to, I take the lengths of the two sides that form that angle B, which would be A and C, and would times it by sine of B. So our formula for area of a triangle could also be 1/2 AC sine of B. But what if I know angle C, and that's the only angle I know about the triangle? How would I find its area? Well, that's obviously going to be 1/2 of the two legs that form angle C, that's A and B, times by sine of angle C. Notice a pattern in these formulas. A, B, C, A, B, C, A, B, C. So each letter is only going to be used once. You're going to have two sides and an included angle. So here I know I'm given A, B, C, so I can use this formula. So the area is going to be 1/2 the product of the two sides times the sine of 120 degrees. All right, we're going to plug this in. So 1/2 of 4 times 6 is 12. Sine of 120 degrees, well, that's on our unit circle. It's in quadrant 2. And the sine of 120 degrees is going to be √3 over 2. So I can simplify that, and my answer is going to be 6 square root of 3. If it's not on the unit circle, you can use a calculator to find the angle measurement, like you will do in this your turn video, this your turn problem. Find the area of this triangle. All right, so to find the area of this triangle, it's going to be 1/2 4.5 times 22 times the sine of 5 degrees in 15 minutes. So I'm going to use a calculator to help me with this. So let's go to our calculator and type in this information. All right, so I have 1/2 times 4.5 times 22 times by, well, let's make sure we're in degree mode. We are. So sine. Now remember to do DMS mode in your calculator. You do 5, you go to the angle button, which is second apps key. And then number 1 is the degree symbol. And then I plug in my minutes, 15, and I go back to that second apps key to get to the angle menu. And number 2 is our minutes. And then enter. So the area of this triangle is 4.53 square units. And that is how you find the area of any triangle. Okay, now we're going to look at solving oblique triangles. And what solving a oblique triangle means is that you need to find the measure of all 3 angles and all 3 sides. To do this, you need at least half the triangle already given to you. So you'll need at least 3 values. To solve oblique triangles, you will need to use either the law of sines or the law of cosines. We'll learn about the law of sines today in this video and tomorrow's video, and then the law of cosines in following in a later video. What is the law of sines? Well, we use the law of sines to solve any oblique triangle when you're given the following data. So again, you're given 3 bits of information. If you're given an angle, side, angle, or if you're given angle, angle, side, or if you're given side, side, angle, then you'll use the law of sines. So let me illustrate what this means from a little diagram over here. So angle, side, angle, let's say I'm given angle A, side C, and angle B. That would be angle, side, angle. An example of angle, 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 side is if I'm giving you, for example, angle A, angle B, and side A. An example of side, side, angle is if you were given side A, side B, and angle A. What is the law of sines? Well, the law of sines is actually some proportions. Okay, it says that the length of side A divided by the sine of angle A is equal to length of side B divided by the sine of angle B, or it's equal to the length of side C divided by sine of C. So that ratio, that fraction that's formed by that, is always equivalent. And it doesn't matter if the sine of A or the side A is on top. So I can do the reciprocal of this and also work it. So I use the reciprocal formula if I'm trying to solve for an angle measurement, and the first formula if I'm trying to solve for a side measurement. So here in this example, we're going to solve the triangle ABC given the 3 bits of data here. So we're going to draw a representative triangle, and we're just going to label our angles big A, big B, and big C. Okay. And then we're going to label our given information. Well, we were given that angle A is 50 degrees and angle C is 30 degrees. And side A is 10. Well, side A is always going to be the side opposite that angle A. And so here we're given angle, angle, side. So that means I can solve this using the law of sines. First thing I want to notice when I'm looking at this is that I'm given an angle and the side opposite. You have to have that one, you have to have one of the ratios in order to use the law of sines. And then the other one, I'm given angle C, but I'm missing side C. So that's the first one I'm going to solve for. I'm going to solve for side C. So that's going to give me that I know that C is to sine of 30 as 10 is to the sine of 50. And then I'm just going to solve this equation for C by multiplying each side by the sine of 30 degrees. And then this is an example of when we're going to actually use decimals in this class. So I'm just going to go to my calculator and I'm going to plug in this information and estimate our answer. So we figure out that C is approximately 6.53, whatever units we're measuring in. What I want you to do on these problems, because there's going to be a couple work areas, I want you to make a little box for all your answers. So in order to solve this, I have side C, side B, and angle B. Next, I will solve for the the angle B. To do this, I got to recall that the sum of the angles of a triangle is equal to 180 degrees. So angle A plus angle B plus angle C is equal to 180. So I know that angle A is 50 degrees. B is what I need to figure out, and angle C is 30 degrees. So solving this little equation, I can end up that B is equal to 180 minus 50 minus 30, or B is 100 degrees. Then to solve for side B, now that I have a half of a ratio, I can do law of sines again. And I want to solve for little b, so I'm going to put b on top, over sine of b, which is 100 degrees, is equal to, now I could use the ratio of the c's, but I round it here, so I don't want to use that because I'll have a compounding rounding error. So you always want to go back to the given information or the one that you did not round on. So that's the portion I would set it up equal to. And then I'll just solve this equation for b, punch this into my calculator, end up that b is approximately 12.86. Now I've solved my first triangle using the law of sines. I'll pause while you do this. Okay, so first thing you want to do is start by drawing drawing your oblique triangle. And label your given information. So I'm going to label this angle A, B, and C. Angle A we know to be 98 degrees. Side angle C is 43 degrees. And side B, which is opposite angle B, 22. And so my 3 bits of missing information is I need to figure out angle B, side A, and side C. So this is going to be my little answer box. All right, so I don't have a ratio here where I have a side and angle opposite, but I can easily figure out angle B by recalling that 180 degrees minus my 2 given angles will equal my missing angle. So I would start this by solving for angle B, which is 39 degrees. Now I have a side in the angle opposite it, so I can use that as my foundation, and I didn't round, so that's going to be my foundation of my ratio. So then I'm going to solve for one of those missing sides. So let's say I'm going to solve for side C, so I'm going to set up my ratio as C is to sine of 43 degrees, as 22 is to the sine of 39 degrees. And then I'm going to solve this for side C by multiplying each side by sine of 43. And I figure out that side C is approximately 23.84. So the length of side C is approximately 23.84. Now I need to figure out the length of side A. So A is to the sine of 98 degrees, as 22 is the sine of 39 degrees. And then solve that little equation for A by multiplying each side by sine of 98 degrees. Evaluating this with the use of my calculator. And we find that side A is 34.62 in length. Now this is how you solve triangles using the law of sines with these first 2 cases. Now we're going to learn about this third case, side-side angle, which is called the ambiguous case, next time.